There's a revolution going on in the nuclear power industry. Where once big was beautiful, now small is the name of the game. Nuclear power plants have been prestige projects for decades, with governments spending billions of dollars on each facility. These large infrastructure projects cost so much in both time and money that only wealthy countries can afford them. However, with the growing climate crisis, the push is to reduce our reliance on fossil fuels for energy generation globally. So, the former black sheep of power generation, nuclear, is being rehabilitated. Nuclear power is increasingly viewed as a vital backstop for energy generation alongside renewables. Small modular reactors, or SMRs, are a possible answer to providing cheaper energy generation at a fraction of the cost of a traditional nuclear power plant.
At some point, you hit a threshold where, just due to the construction complexity of these giant mega projects, they all started running over price, over budget, over time by huge margins. You start a project thinking that it was going to be $5 billion, and all of a sudden it's $15 billion. That's happened many times in the nuclear industry. And so this drove a rethink about how nuclear power plants should be built. And so over the last decade or so, the industry has thought, well, if we start bringing in, let's say, passive safety systems or autonomous and digital control of the nuclear power plants, maybe we can relax some of these requirements that were driving up that initial large fixed cost for the big plants and open up economic feasibility for much smaller plants.
A typical small modular reactor will produce no more than about 300 megawatts, making it small compared to standard nuclear power plants. As we will see, some can be as small as just 20 megawatts, enough to power a large factory or a neighborhood residential area. An SMR can be modular in two distinct ways.
If you need, for example, 1200 megawatt electric, you don't need to acquire a 1200 megawatt electric big reactor with all the high capital costs and so on. You acquire, say, 300. And if the needs arises, you acquire another 300 and you keep building up until you reach the desired power. And that provides what they're calling economy of multiples rather than economy of scale. It's less risky in terms of upfront financial obligations, lower financial risk, and it's more flexible. The other definition of modular is to build the small reactor in small modules off-site in a factory, bring them and assemble them on-site. The idea here is to reduce the cost of construction and the time of putting together the reactor. That concept of modular design, modular fabrication, modular construction is not new.
No, modular construction is not new, and many companies developing SMRs borrow construction techniques from automobile and shipbuilding. It's estimated that more than 60 firms worldwide are developing small modular reactors. Some are well-known names like Rolls-Royce and Westinghouse, and others are startups like Last Energy in the United States. Last Energy is adopting the two levels of modularity to build micro-power generation reactors.
Our choice of 20 megawatts was actually an optimization across several different parameters. The ones that we started off with the highest weighting when we tried to decide what is the design criteria of what we're actually going to build, was twofold. One were logistical and supply chain considerations. And what we wanted to do was make everything road transportable and manufacturable on these steel skids, these almost Lego block-like construction increments. And so in order to do that, we wanted to constrain ourselves downward, but we wanted to maximize the power within that envelope. And so that's how we arrived at 20 megawatts from a supply chain and logistical perspective. We then overlaid that with business model considerations and found that many industries hover around 20 megawatts as part of their industrial unit of power consumption. Most notably, the data center industry happens to also use 20 megawatts exactly when building data center increment blocks. There's an incredible number of applications for this type of technology, because you could think of it as a one-to-one pairing between a factory that needs 20 megawatts, let's say like a pulp and paper factory, one of our prospective customers in Wales. Our increment size matches that directly. Or you can think about, let's say with a hyperscale data center customer, they might need 100 megawatts. And so what you can do is you can pair 5 of our identical units together to be able to hit that increment. 20 megawatts also happens to be the size of a standard municipality. So if you have 20,000 homes, American homes, in a town, they would need 20 megawatts as well. But you could also think of extending this logic even further and saying, well, what if there's a city that has 1 million people in it and they required 50 of these 20 megawatt increments? Well, why not? Why not just get a field outside of that city and team up 50 of these units together? So I think that the applications really are quite flexible and vast when you work in these defined increments of power output.
So far, there are no commercial small modular reactors in operation, and they are certainly not on the micro scale. Russia's Akademik Lomonosov is the nearest equivalent, a floating nuclear power and heating plant. It's far from being micro. In the early 2000s, Russia's Rosatom announced its intention to produce 7 identical small nuclear power stations integrated into ships. The floating power stations use reactors similar to those in the country's fleet of nuclear-powered icebreakers. The first, and so far the only example, is the Akademik Lomonosov. After being built in St. Petersburg on the Baltic, it sailed to the Arctic Ocean. It's now berthed in the port of Pevek in the Chukotka region of northeast Russia. The Akademik Lomonosov provides the town of 4,000 with electricity and heat, although it's powerful enough to supply energy for a population of 100,000. So, can we expect to see small modular reactors in commercial operation?
We've already built 3 full-scale mechanical prototypes. And then our next set of prototypes coming up in the next year or so are going to be fully functional but not nuclear. And then our target is maybe a year, year and a half, hopefully not 2 years after that, have our first fully functional nuclear fuel inside the reactor running, operational, to be able to demonstrate our first plant. So we're targeting around 2026 at this point, maybe 2027 if worse comes to worse.
The manufacturers are working in a similar time frame. With increasing concerns over climate change, nuclear energy is touted as a less damaging economic answer to our energy needs. With only 3 serious nuclear accidents in approximately 20,000 years' worth of operating experience, few industries can boast such a safety record. For example, even though the 3 nuclear reactors at Fukushima went into meltdown, nobody died from the effects of radiation. Public concern over safety is still a major sticking point, despite the vast improvement in nuclear power plant design over the 1960s technology involved in the accidents.
The good number of nuclear new emerging design rely on the concept of being inherently safe. For example, there is what's called the trisulfide, the triple-coated fuel, that will maintain the fission products radiation within, so it will not get out. A number of reactors also rely on passive safety systems, which wouldn't require a mechanical pump, for example, to actuate flow and so on. Put it this way, the choice we have now is essentially risking it all by damaging our Earth and our human existence and existence for other creatures, or go with something that is quite reliable and we have experience in. It's not completely new.
That built-in safety is one of the selling points for the new designs of small modular reactors. Even though they use very little nuclear fuel, the issue of dealing with SMR waste has to be addressed.
That small amount of waste, which is really a small volume, and that's a big thing about nuclear. It's not a huge waste that is dispersed all over the place, will decay, the radiation will decay to a level where it becomes accessible and you can extract some precious minerals and can actually extract some material that can be used as a nuclear fuel. So in terms of sustainability, which really people talk about that we are benefiting now and not benefiting future generations will benefit from that.
Nuclear fission is clearly able to provide some use after power generation, and what was viewed as waste is today being seen as a resource.
What you've done is you have performed alchemy. You have transmuted many different normal stable elements to unstable isotopic versions. Now that unstableness is essentially what is giving off energy, giving off radiation, and what causes toxicity. But in extremely microscopic quantities, it can actually just give off an energy signal that can be used across a variety of applications in industry, including greater safety. So when you look at your fire detector, that has a little bit of radioactive waste in it, giving off such a particular signal, going across to a sensor that can read that signal, and if smoke passes in front of that sensor, then your alarm goes off. And so there's just so many beautiful ways that we can imagine repurposing nuclear waste, spent fuel, whatever you want to call it, that actually increase both the prosperity and safety of society. And so we want to refocus people's thinking on that to address the public perception issue, rather than just shove a bunch of technical scientific papers in their face and saying it's safe.
And that safety issue in the public's mind is probably the biggest hurdle for the blossoming SMR industry to overcome. No doubt, today's nuclear reactors are vastly safer than those designed at the birth of atomic power. So maybe we have to ask ourselves a simple question. Which is safer? A product made in the 1960s or something made today?
Remember to hit the subscribe button and ring that bell to stay updated with our latest content. And while you're here, why not check out another one of our exciting videos? Thanks for watching, and see you in the next one.